So guys, today we will be talking about functions in Spark. So basically when we talk about functions, right, functions can be divided into multiple categories. The first category of function is called aggregate function. Aggregate function. And the second category is called, let's say, analytical function. And one more category is, let's say, some grouping function, which will return one row at a time. Let's call them a grouping function. Right? So now, there are three types of function, and the fourth type of function, which I already explained, is called UDF. We will not be covering this because we already covered it in other lecture. So let's talk about these three functions in a lot of details. Let's say if I have a table, employee, EMP table. In this EMP table, I have employee numbers from 1 till 1 million. Then I have their salary from, let's say, 1,000, 2,000, and let's say 5,000, whatever salary it is. And let's say only 2 columns are here, right? So if I ask you, what is the max salary of employee table? Which employee is earning the max salary? So in this case, we can clearly see the employee which is at 1 millionth row, that the employee number 1 million is earning 5,000 and it has the highest salary. So it means the grouping function will return one row for the full table, right? Grouping function will return one row for the each table, because we can call them in this way. 1 second. So let's say that aggregate function is further divided into two parts. Let's make it more simple. Table aggregate or grouping. Right? When we talk about table aggregate functions, they will generate one row for the full table, like max, min, count, different kind of stuff. When we talk about grouping function, grouping will do the same aggregation, but for certain group. So let's say we have one more column here, department, and the CS, mechanical, and civil, whatever, right? And if I ask you, okay, guys, what is the max salary for CS department? Then we can clearly see here that max salary for department CS is 5,000. So it means we are looking for some group. And we are generating some rows. Let me write it here again. So we have employee table. In employee table, we have 1, 2, 3, 4, 5 employee number, right? And then we have salary here. And then we have, let's say, department here, same thing, right? So the salary is 1,000, department is CS, salary is 2,000, department is mechanical, salary, let's say 1,000 again, department again civil, whatever, and then 2,500 CS, and 5,000, and let's say civil. If I do the tabular aggregation function, which will work on the full table, and if I ask you the max salary, what the output gonna be? The max in case of table aggregation. So the result will be 5,000, right? This will come as a highest salary. Now, if I do the grouping on department, and if I ask you the max salary, what it will do? It will see, okay, CS, I have 2 rows and the 2,005 row, CS 2,500, civil, I have 2 rows, 100, and then it will be 5,000, and mechanical, I have only 1 row, and the salary gonna be 2,000, something like this. So it will generate 3 rows, depend on number of groups, right? So this is your tabular aggregation function. This is your grouping function, or the grouping will work on the basis of grouping key. Let's say if I'm grouping on this. Now one more functions are there, which we call windowing function. So what windowing function will do? It will do the same thing. exactly the same thing. Let's say if I want to find the max salary for each department for this table, so what it will do, the windowing function, it will create a window first, and I'll explain it, but the result gonna be like this: 1,000 and CS, and the max salary for the CS. What is the max salary for the CS? 2,500. And then again 2,000. Then mechanical, what is the max salary for the, it is 2,000, right? And then 3,000, and civil, and 5,000. So it will generate the max salary, but it will give you the same number of rows what are there in table. It will create a new column, and it will give you a new value based on the function you have used. In this case, if you use the max value, right? So if question arises, what is the difference between grouping function and the windowing function? So the grouping function will give you number of rows depends on the distinct value of the grouping key, right? In this case, we have 1, 2, and 3 distinct value in the grouping key. So we got 3 keys or 3 rows here. But in case of windowing function, if we go for windowing function, we will get the same amount of rows, same number of rows, which are there in the base table. So it will be CS again, civil again. Civil salary is 5,000, right? And CS salary, the max salary for CS is 2,000. So it will come 2,000 again. So what we came to know, that grouping function will give you max number of rows as the number of distinct keys, and windowing function will give you the same amount of rows as there in the base table, and it will put the calculator aggregated value in front of each row, right? This is how the grouping function works. Now let's go to our Spark SQL again. So let's see in this way. So when we go about aggregate or grouping function, it will give one row for a certain group, but when we go for windowing function, it will give one row for each row with the aggregation, with a new column for the aggregation. It will give only one row with the aggregated value for each group, right? The grouping function or the aggregated function will generate one row for each key of the group, and windowing function will generate same number of rows as there in the base table, and it will put the aggregated value at the end of each row. Okay, so this is how it will work. Okay, so now let's jump into practical things. Yeah, so this one. Okay, so what I did here, I copied a good example from the site Spark by example. Okay, and what I did here, and that I created the same thing what I was telling you guys, that okay, I have a table in which I have 3 columns: name, department, and salary, right? And then what we need to do, we need to do different kind of stuff. Let's say we need to find the aggregation, we need to find the max salary, min salary, right? So let's try to run this and let's see the result. And meanwhile, while it's running, I'll explain it to you. Okay, so what this code is doing, it is creating a DF, right? And it is then doing different kind of aggregation function. The first aggregation function is, it is doing the counting, the average approx count of the distinct salary, right? 1 second, just 1 second. Why it's not running? Run as Scala application. Let's see what it is giving in error. Let's see quickly. What? Okay, it is working. I'm not sure what the issue is, but it is working for us, right? So let it run, and meanwhile I was explaining it to you guys, right? So let me start again. So what we were saying, that we created a data frame for the department, for the employee table, and then we give the structure to that department, right? And then we are trying to write different aggregation function on the data frame for each aggregated function, right? So let's say we want to count the distinct values, approx distinct values. So what we can say, df.select, and then the aggregation function name, and then the column on which we want to go for, we want to calculate the result. So in this case, we want to go for salary. Now the question arises, why we did 0, 0 here, and it's a very good example. So why we did 0, 0 here, just to see the exact value. If we remove the 0, 0, it will give the row element to us. I'll maybe show it to later, okay? And most of the functions are almost equal. Let's say we want to calculate the average salary for the whole group, will go something like this, right? And let's say we want to do max, min, skew, standard, whatever. We can do everything here. So how it works, let me explain it to you guys. So this is our table, and this is the first type of function what I was explaining it to you guys, which is one row for each table, one row for each function for each table. So here what we see here, that the number of distinct row, approx number of distinct row for salary is 6. Average salary for the whole employee table is 3400. And this is interesting function. When we want to collect some column in form of list, there's one function here in Spark Scala, Spark SQL or data frame, that is called collect list. And we can pass the column here, and it will generate a list for us. So this is the list what it generates for us, and we can parse through the list if we want to have, right? And if we want to have set, see, there are two functions. One is collect underscore list, and one is collect underscore set. What is the difference? That in list we can have duplicate value, but in set we don't have duplicate values, right? So we have two functions on the table aggregation, that is collect underscore list, collect underscore set. Now distinct, if we need to find how many distinct department and salary sets are there, in distinct we can pass multiple values. So we can say how many distinct departments are there, or how many the combination of department salaries are there. So what we can see here, that there are 8 different distinct department and salary. Similar, and one more thing. So what is the first salary? What is the last salary, right? And if I go here and show you how it works, yeah. So first salary means the row which is coming at first. Last salary means the row which is coming at last. We can do the order by as well, and we can see which salary is coming at first and last, right? And if we want to do multiple functions in the same query, then we can go for aggregation. I'll show you guys later. But we can do n number of things: maximum, minimum, mean, skewness, standard deviation, summation, sum distinct, whatever. But what I'm trying to show you here, you will always find only one row in the output. It will only generate one row for the output, because this is doing aggregation on the table level. There is no grouping. Or we can say, if the grouping is done for the whole table, and it gives us the result, right? Now let's go for aggregation function, and which is grouping function, okay? And let's try to run this. So what I showed you with the group, it will generate number of rows which will have number of rows is equal to the distinct keys in the group key, okay? So what I did here, the same thing I did here. So here we have employee, department, city, salary, and age and bonus. So I have few other columns. So employee name, department, state, salary, age, bonus, etc. And then what we can do here what I'm doing. So here, if you see, it's very simple to read. We have created one data frame. Then what we did, we are grouping the data frame, all the rows. See, data frame is nothing but a distributed table, right? Data frame is nothing but a distributed table which is distributed across different executors. So you, as a developer, we do not need to think when we code, but what Spark will be doing when you are doing grouping, by, it will do the shuffle, it will read the same keys, and it will give the result to you. Okay. So what it is doing, that we are grouping all the rows of this data frame by department, and then we are counting it. So what this particular row will give us, it will give us the department and the number of employees working in that department, right? If I go for group by department and the average salary, what it will do, it will group the same department together, and then it will calculate the average salary, right? So if I explain it to you in this way, so we have, let's say, CS 1000, and for, let's say, ABC employee. For XYZ employee, it's CS again, and his salary is 2000. And for MNO employee, it's civil 1000. And again, let's say some NIL, and he works in CS, and salary is, let's say, 2000. So if I do the grouping by department by this column, ideally what it will do, when it will do the grouping, it will bring all the same keys and values to some other row like this. So what it will do, let's say, it will bring something like this: CS 1000, CS 2000, and CS 2000. So now it will have a separate data structure. And let's say now if we want to calculate the max salary, then it will clearly give us 2000 for CS like this. And for civil also, it will create the same structure like this. So it will be civil, only one row is here, so it will say 1000, right? If we put the sum, then it will only sum the CS department, because it created a separate table behind the scene. This is called shuffling of the keys, right? Now let's go here and let's see how data looks like with different operations. So what we have here, we have employee table with 7-8 employees. We have their department, sales, finance, and marketing, 3 types of department. So as I was telling you guys, that group by aggregation will generate the number of rows is equal to distinct number of keys in the grouping key. So how many distinct keys are there? 1, 2, and 3. Sales, finance, and marketing. And see here the result. Since we have group by department, so in department we have 3 distinct departments, and it counted the employees working in each department. Same thing and it will be applicable everywhere, whether we are doing count, whether we are doing average, maximum, summation, whatever you want to do, it will always generate 3 keys, 3 rows. See, max salary, minimum salary, average salary. Now this particular thing, why it generated 5 rows, and let me show it to you guys. The same concept will be applied here. Yeah. So when we go here, in fact, when we go here, what it is doing, since it is grouping the data on 2 particular columns, department and state. So it will find the distinct combination of department and state. So the distinct combination of department and state is 5, and that's why it is generated 5 rows for us. Okay, and it will be applicable everywhere. Okay, now let's say we want to do multiple aggregation in the same operation. So what we can use, we can use .agg function. So obviously grouping will be working like this, and since we want to do multiple aggregation here, then we will be using .agg function, and we can put all the aggregation inside that agg function. So it will work something like this. So it will give you everything for each department. In fact, this one. Okay. One more thing, let's say if we want to put some where clause at the end, let's say we want to do multiple aggregation. Obviously we will be doing first grouping by dot group by key, then we will do for dot agg because we want to do multiple aggregation here, right? And if we want to filter all the aggregated rows, based on some aggregated value. So in this case, what I did here, and let me explain line by line, this is important. So what I did, I grouped the whole data frame based on department, and since I want to do multiple aggregation, I use .agg clause. Inside .agg clause, I calculated 4 things. What those 4 things are: average salary, average sum of the salary, average salary, sum of the bonus, and standard deviation from the bonus. Now, let's say if we want to filter some rows based on the aggregated column, we will use the where clause here, and then we will use something like this. Okay. Now, one more question: why we are using false here? So by default, the trunk false is here in the show function. False give that okay, we don't want to truncate any data in any particular column. So if I show something like this, it might not give the full data to us. It may give something like here. Okay, so false stands for if we want to see the full data of the column, right? So I think I don't remember the limit up to which Spark shows the column data by default, but after a certain point it will start truncating the column value. So let's say if your name is something like this, so if you don't use the false keyword in the show, it might truncate your name till here, and it will show ... at the end, something like this. Okay, and that's why if you want to see the full data, we'll go for false. So now we came to know 2 things. One is table function, which will give 1 row for the full table. Then we go for grouping or aggregated function, which will generate 1 row for each grouping key. Now let's go for windowing function. So as I was explaining you, windowing function will generate same number of rows as there in table, right? And let's see how windowing function works. So let's first see what we are doing. We are almost doing the same thing. We have created employee table, employee data frame. We gave the structure to the employee data frame. When we talk about windowing function, right? So windowing, now before we jump what windowing functions are, how windowing function works, let's see what exactly is a window. So let me copy this data. In fact, let's copy this data because it is in proper shape. So here we can see that we have sales, finance, marketing department, we have departments, state, different kind of stuff, right? So what windowing means, that we need to give a window or calculation window for based on certain element. In this particular case, if let's say if I want my calculation in this particular case, let's say if I want to base my calculation based on department name, what I want that for each department give me the max salary. So what it will do, if we are using windowing function, what it will do, it will create 3 windows for us. So this will be your first window, this will be your second window, and the marketing will be your third window, right? And then it will apply the max key or the max aggregation function on each of the window. For in this case, if I go for max salary, we can clearly see the max salary is this one. Then it will put 90,000 here. And the good part about windowing function is it will generate the same value for each window. So 90,000. Here the maximum salary is 99,000. For these 3-4 rows, it will generate 99,000, 99,000, and for this row it will generate 91,000 and 91,000. So what exactly I want to show you here, that to run the window function, we first need to define the window on which that aggregation function will run on. So into our case, let's say we define the window based on the department name, and then on this window we will run some aggregation function, right? So when we jump to Spark code now, so what we see here, that we first need to define the window specification in the windows, and let me copy that so that it will make more sense to you guys. So when we define the window specification, we can give any name here, obviously. We need to use the Windows keyword, and inside the Windows specification or after the Windows keyword, we need to tell Spark that, okay, on which column you need to define the window. So this particular partition by clause will tell Spark or the execution engine that, okay, guys, please define the window based on the department column. So since we defined the window based on department column, it generated 3 windows for us. And inside that window, inside this window, so what exactly Scala will be doing? It will create 3 windows. So let's say this is your first window, right? So it will copy the data somewhere here. And then what we are saying, inside each window, do one thing, order the each row by salary. So here we see that 10,000, 20,000 and 20,000, it's already ordered. But let's say if this row is at the first place here somewhere, then what it will be doing, once it copies that window for processing and we say order by salary, it will generate this data from this data because it will order the rows by the salary. Okay, so when we define the window, the mandatory clause is partition by clause. We may or may not give order by clause. It's optional. Okay, so let's say. So now let's go to our code. So what we did here, we defined the window specification, and in the window specification, we asked that, okay, please divide the whole data into number of windows based on department, and inside each window, order by each row by salary. Okay, and then going further, we will be using this window function for n number of operations. Okay, so let's see. So the first operation is, okay, now before I jump to the operation, how we need to use the window function, right? So there are multiple ways to use it. The easiest way to use the window function is this. So what will say? We will be calling with column clause on each data frame to create a new column, and then there are multiple types of windowing function, right? There are multiple types of windowing function. There are some specialized. So the windowing function are further divided into 2 categories. Some aggregation function, for example, max, min, sum, average, these can be used as the windowing function, but there are some specialized window function like row number. So when we go for row number, so what I'm telling Scala to do here, or Spark to do here, that generate row number for each partition, and each partition where rows are ordered by salary, right? And then give a unique number to them. Start with 0. This is what I'm telling Scala when I'm writing this window function, right? That df.with column generated new column, name that new column as row number. The value of that row number column should be, use the row number function, and to generate this row number function, use this window specification, and to use the window, we will always use over clause. So now, since one new clause came, let me explain other details. So when we go for windowing function, Windows function work like this. So the function name, whatever the function we need to do, right? Then we'll say over, and then we will say window specification. So the function name can be of n number of types, and those functions are Spark SQL. Yeah. So those functions can be rank, dense rank, entile, percentile. So we are right now using row number. So what we are doing that, okay, df means data frame dot with column. With column means generate a new column. What should be the name of the new column? Let's say rn, right? And inside that new column, do one thing. Use this row number clause or row number function. So we'll just copy row number. So we'll say row number. Over this row number, use the over clause. And why we are using over clause? Just to pass the window specification. So we'll pass our window specification and we'll close this. So this window specification we already defined on the first step. What this window specification says, but okay, divide the whole data. What Windows specification says, divide the whole data, partition whole data based on department and order each row based on salary, right? So this is what is working. Now let's see how it is working. So if we go to our code, since I already run it. Oh, I didn't run it yet. So let me run it now. So now while it is running, let me explain all the windowing function for you guys. So the windowing function are basically divided into two categories. The first category is called ranking function. Ranking means to give some number to each row. And the other category is analytic function. Analytic function means generate some value based on the data. Like for example, if we have salary column, then generate some column value based on that salary. Here, we don't have to, like obviously this ranking, dense ranking, whatever different functions are, which I'll be explaining it to you, based on the data, but their value is a unique number, 1, 2, 3, 4, 5, 6, whatever. But this number or these values for the analytic function will be some value from the data, right? For example, last value, let's say if I apply last value function on salary, obviously it will be sum of the salary, 10,000, 20,000. But if I say rank, it will be 1, 2, 3, right? So let it run. And yeah, one more thing which is very, very important, that when we talk about windowing function, windowing function work like this. So one thing we know, that when we talk about windowing function, window function will act on the full table or full partition. Partition means some part of the table based on the grouping key or based on the partitioning key. So let's say this is your one partition. Let's say this is your CS department partition. Partition, right? This is your one partition based on Windows specification. So this partition will be based on Windows specification, right? So how Windows functions work, for each current row, it will look for and preceding rows, and the preceding rows in case of Spark we call them unbounded precedings, and all the following rows. So in case of Spark or in case of windowing function, we call all the following rows as unbounded following. I'll explain it to you. What it means that, okay, let's say if I want to find the salary of next employee, let's say I have 4 employees, 1, 2, 3, 4, and the salary is 1,000, 2,000, 3,000, and 4,000. What I want to put after each row, I need to put the salary of the next employee. So for this, the salary of next employee is 2,000, so it will get 2,000 here. For this, the salary is 3,000, so 3,000 here. Like I'm finding the lead salary of the next row. For here, the 4,000, and since here there is no next row, it will be null. So what it means that, and this is the application of lead function, right? This is the application of lead function. I'll explain it in a lot of detail. For lead function, we need to know unbounded following rows, right? If we go for lag function, we need to go for unbounded preceding rows. So this is what, in each partition, we have unbounded following and preceding rows to be known, and Spark maintain it on our behalf, okay? Let's say if our code has been run, perfect, it ran. So what we have into our data, let's minimize this section. Yeah, so we have 5 rows for sales. In fact, let's go from here, right? So what we have, that we have how many rows? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 rows, and there are 5 employees who are working in sales, then 3 employees are working in finance, and 2 employees are working in marketing. Now what we asked, the first function was that, okay, generate, let's go here, generate the row number, just produce one row number for each department's employee based on order number salary. So how many departments we have? We have 3 departments. Into the sales, we have 5 rows. Into finance, we have 3 rows. For marketing, we have 2 rows. What we did, since we have used this row number function, and we use Windows specification into that row number function, and into the Windows specification, we asked that partition by department and order by salary. So let's see how it works. And let's see now. So this is our table. We asked, let me copy this so that it will make sense. Let's copy this both. Control C, and I'll paste it here. Okay, so this was our input. What I asked, that, okay, give a row number to each row of each partition. So what this guy did for me, that, okay, it copied this each row. It will copy here, then it will copy all the sales rows. So this one is sales, so it copied it here. So because it is creating the first partition, so first it will apply the Windows specification, right? So it didn't copy it, but Control C, and then it will paste it here, and that last row it will paste it here, something like this. And then what I asked it, that, okay, first create the partition, and inside each partition order each row by salary, right? So what it did, it ordered each row by salary. So this we have 3,000 as the least salary, so 3,000 will go here, and then we'll remove this, it should be cut, and then 4,100 rows should go at the top, right? And then it will, since row number means give one unique number to each row, so it will be 1, 2, 3, 4, and 5. Let's see how the result came. This is how it worked internally. It created the partition, it ordered them based on the order by key, and then it generated some result for us. See this. So this is our result, and this is what I was writing. So these 2 results are uniquely exactly same: 3,000, 3,000, 1, 2, 3, 4, 5, right? And this is how which function work? Row number. So what row number did for us? Row number generated one unique number for each row based on the Windows specification. Windows specification means partition key and order by key. Okay. So this is how row number works. So row number will generate one unique number for each row based on the partition and Windows specification, right? So in simple terms. Now, what ranking is? So this is very, very important topic, and it is asked a lot of time in your Spark and SQL based interviews, right? So let me explain ranking in a lot of details. So when we go for our Spark SQL, we have ranking function and dense ranking function, right? And let's go to this here. So here what we are seeing that, okay, we have 10 rows, right? We have 10 rows. We have 10 rows. Now we have Windows specification based on department, and we want to order the rows by salary, something like this, right? So what we did here that, okay, in the row number it came 1 2 3 4 5, because obviously row number is a distinct number for each row. But if I want to give ranking, how it will work, let's see. So if we work with ranking, what it did for me, since we based, okay, let me do one thing first. It is actually order by, in fact, let it be 1 second. Okay, so let's say first rank means lower salary and high rank means higher salary. Obviously let's assume like this, since we haven't put the order by key, by default it is ascending. If we don't give any key here, by default it is ascending. Okay, so that's why it put the ascending order. So now let's copy this there and let's remove this portion and paste it here. So this was our raw data, right? What we did, we partitioned by department, ordered by salary in ascending order, right? And then we asked that, okay, give a rank to each row in each partition. We ask for rank. So what rank do for us, it will give rank based on the order clause, right? So based on the order clause, what is the first row for sales? 3000, so it gave 1 row. Since we have 2 rows for 3000, it again gave 1 row. But when came the next row, it gave 3. So 1 1 3. Ideally in ideal world it should be 2, right? So if we are using ranking, it will generate in case of tie. So obviously this is tie, right? Tied here. So in case of tie, it will skip the next number and it will generate the number of rows. So what I want to tell you here, that in case of tie, it will skip the next rank and produce the rank plus 1 rank. For example, in ideal scenario, it will be, in the case of tie, it should be 1 1 and the next rank should be 2. But what it did, since it is a tie, it skipped the next rank and it give the 3rd rank. So this is how ranking work. So in case of tie, it will skip the next rank and will produce the next rank. It will give the next number of the first ranking. So after 1, it gives 3. After 3, it gives 5. Right? Let me show you quickly now. So this is your tie. So it skipped the next number, it gave 3. This is the tie again, and it gave 5. Right? So in case of tie, it will always give the next number skipped. It will skip the next number and it will give the last number, right? And if we want to know the formal definition, let me search it for you guys. Rank versus dense rank. So let me put that into words. So rank gives you ranking where your ordered partition ties are assigned the same number with the next ranking skipped. Okay, let me copy it for you guys. So rank gives you ranking within your ordered partition. We know this thing that, okay, our ordered partition is department. Ties are assigned the same rank. Yes, the same ranks has been assigned to the ties. Perfect. With the next rankings skipped. Yes, the next ranking supposed to be 2, but it was skipped, right? And then it is not written here, but let's see, if we click this link, it will give us all the details. So it is almost saying the same. So if we have 3 items at rank 2, the next rank will be 5, right? So same thing what I was telling you. Now coming to the dense rank. So what dense rank is saying, Dense rank again gives you the ranking, right? So rank and dense rank will give you the ranking based on some column. Into our case, the column is salary. Dense rank will give you the ranking within your ordered partition, but the ranks are consecutive. No ranks are skipped. If there are multiple ranks, then there will be, so for example, let me see here. Let me copy the dense rank one. So how dense rank works, there is no skipping of the rank. There is no skipping of the rank. So let's paste it here. So for the first row, we have a tie, but since it is dense rank, it didn't skip the next row. So it always go for the next consecutive rank. And then here it is 3. One more important thing to notice, and that in case of ranking, the last rank will always be equal to the number of rows in the into that partition. In case of ranking, the last rank will always be equal to the number of rows in that partition. So in this particular partition, how many rows I have? 5 rows. So the last row will always be 5. But in case of dense ranking, it doesn't matter how many rows are there in partition, because in case of tie, it is not skipping the next rank. It will always give the next rank in the consecutive way. This is how your dense rank works, right? So now, this is the most asked interview question, that okay, what is the difference between rank and dense rank? How will you implement rank and dense rank in Spark? So to implement any analytical or windowing function, you need to first define the Windows specification. In the Windows specification, you need to define your partition by an optional order by clause, and then you need to use that Windows specification using over clause into your data frame, right? So this is how your dense rank will work. This is important because I'm just covering only important function. So let's say we want to go for lagging. Lag function means, okay, tell me what is the salary of previous element in this particular partition. What is the salary of previous row in this particular partition? So in this particular case, one more important thing, right? Since we have based our partition, based our Windows specification in the ordered way of salary, right? Salary is ordered. So for it will be considered as one row, like one value. And since this is lag function, what is the previous salary of 3,000? Nothing. So that's why it gave us null, right? Now, in case of 4,100, what was the previous salary or the lagged salary? It is 3,000. So it gives 3,000. In case of 4,600, what's the previous salary? 4,100, right? So this is your one partition. This is your one partition done, since we have used the same Windows specification. In case of 3,300, what is the previous salary? Nothing, because this is the first row. For 3,900, what is the previous salary? 3,300. Sorry, 3,000. That's what it came here, right? And in the marketing, obviously, this is the first row, so it haven't come, right? Let's go here. And lead also works in the same way. So one more thing, right? Why it is not working? Let me show you. Basically, it might have rank, dense rank, entile, salary too. Okay. So basically, when you see here that this question should be asked by someone, but nobody asked. Let me explain. Here, we have used, when we go for a league or lad function, we can pass 2 arguments. One is your salary or the column, and how many rows we need to see forward or backward. So in case of lag, how many rows I need to see backward? I'm telling, okay, see 2 rows. See 2 rows behind, and then tell me the make a bunch of 2 rows, and then tell me the salary of like previous row, right? So what it says is, consider these 2 rows as one. It never find any other 2 rows behind this, so it will say null. Then it plug in these 2 rows, and then it find the 3,000 here, right? It plug in these 3 rows, these 2 rows, right? Sales, and it give 4,100 here, right? And for these 2 rows for marketing, it never find anything because only 2 rows are there. So the previous bunch of 2 rows is not there. The previous bunch of lagged 2 rows is not there. That's why the value is null. For these 2 rows, there is no previous row for finance, so it gave null. But for this particular row, what is the -2 row? What is the -2 row? So this is -1 and this is -2, and that's why the result is 3,000 here. Okay. So, and if we skip it, if we don't want to give any number, we can say it will by default is 1. In lead and lag, the by default 1 number is there. How many rows we want to take ahead and 1, right? So it will be 1 or 2. Okay. The same logic applies here, that we can partition. We can in this case, right? As I was telling you that, okay, I am creating a new Windows aggregation specification, and here I haven't ordered it. So I have a new Windows specification, and then inside this Windows specification, since I want to do multiple columns together, what I'm saying, okay, df.with column. So let's see here. So df.with column, and okay, this is something different. Let me explain it to you. What we are doing here, that we are doing multiple aggregations, Windows aggregation in the same way. So it is something like this, dot delete. So it is, if we want to add multiple columns, so we will say df dot with column, do some aggregation, then again dot with column, do some aggregation, then again some with column. So it will be like dot with call, again some aggregation. So this is what we did here. So till now we have done every aggregation till here, and now at the end, after end of here, what we say where and row is equal to triple equal to 1. So when we say here, so row means 1. So with column we gave 1 row column here. So what we say, where row is 1. Row is 1 means give me the first row. How row number works? Row number works like 1, 2, 3, 4, 5. It will give us the row number for each row, and we are telling that, okay, give me the row number 1 for each row, and then select these particular columns like sum, min, max, and give me the data. And let's see how it works. Okay, so this is how it works, right? Now this is important. Let me explain. So what we are telling this function, that okay, just give me the first row. Just give me the first row of each partition. Just give me the first row of each partition, and from that each partition select average, sum, min, and max. So let's say if we do something like this, and we paste it here, and we don't want this where clause, just for a timing, okay? And we say dot select, and let's run this. Sorry, something is wrong. No. So what I'm doing here, oh yeah, so let's call it val df1. Okay, so let's run it down. It was giving error because we are assigning, trying to assign val, reassigning the val. Okay, so what I'm showing you here, how it worked. Okay, so while it is running, let's cover one more topic quickly. So when we go for Spark SQL, so again, windowing function are divided into 3 categories, right? The first category is some aggregation. The second category is ranking. The third category is value. When we talk about ranking, the ranking is further divided into two types of ranking: dense rank and rank. And then we have row number, and then we have entile. Entile I will cover, it's very simple. But when we talk about value functions, Then we have lead, lag, first value, last value. Lead means show me the data for the next row. Lag means show me the data for the previous row, right? Summation, minimum, aggregation, you guys already know. Now, one important question which should come into our mind that, okay, why do we need this kind of function? Why do we need window function? What is lagging into aggregation function that people need to discover this windowing function? The answer is, whenever we want to compare something with the previous period or the next period, or whenever we want to compare first row, number of rows with each other, right? For example, let's say, let's take the example of lead and lag. So let's say if I have the data set for revenue for 50 different years, right? And I want to see the difference between revenue of each consecutive year. So let's say in 2000, I have revenue of 2 million. In 2001, I have revenue of 2.5 million. And 2002, I have revenue of, let's say again, 2 million. And now my boss asked me that, okay, what is the revenue? What is the revenue difference in 2 consecutive years? By using generic function or generic aggregation function, you cannot do it. You need to calculate the difference. You need to have something like this to calculate the difference here. So you need this value and this value. So you will go for which function? You will go for lag here. So you'll put 2.5 here. You will put 2.0 here, and you will put null here, right? You will use lag function, and then you will subtract these values. And for this particular row, the revenue increase is 0.5. This particular row, the revenue is decreased, so it will be minus 0.5. And obviously, this is null because next year is still there. The data is not there. This is where you will be using lead and lag in practical applications, where you will use ranking. Let's say if I want to do the ranking based on the employee salary, I want to see who, and let's take other example. Let's say if I have college students and I need to see who got the first ranking, and obviously we cannot see the ranking based on the simple aggregation function. We need to do the window specification first based on the marks, right? And then we need to do the ranking, right? This is where it works. Now let's see what I was doing. I was showing you guys that, okay, how it was working. Let me copy this thing and this thing, and let me show it to you how it worked. So no, it didn't work. One second. Dot show. One second, guys. So what I was doing here, so I divided it into department and then average. Not sure, but ideally I won't be doing it, but ideally what this function is doing, it is, I was trying to explain this function, right? So it just picked the row number 1 from each row and then gave the department average, summation, minimum and maximum from each row. Okay. One thing what we feel here that, okay, to do these things is very, very complicated, especially for the people who don't know, Scala or maybe data frames. So what Spark gave us an option for Spark SQL, or what we can do that rather than going for this much pain, if we have some data frame, we can, if we want to run SQL like queries, then we can go for, we can create some temporary tables like this, and I'll cover this in the next lecture. So we'll say temporary register temp table, and then we'll say, let's say table name is employee. Now the best part about this is when we do something like this, what it will do for us, it will, if we want to run any single query, right? So let's say we want to run Spark dot SQL, and let's say if I want to run select star from EMP dot show. Okay, and then let's comment everything till the end. Okay, and let's run it. So what that thing was doing, since most of the people are very used to of writing SQL, right? Most of the people are very used to of writing SQL. What that register timetable will be doing, it is creating a temporary table for us so that we can run our SQL-like language query onto the data set. Okay, but behind the scene, obviously everything is same. Let it run, and I will be covering this in a lot of detail tomorrow, but let this come. Yeah, so what I did here, I just registered that data frame. I registered a data frame into a table. Basically, why it's not working? Yeah, it came now. Right. So what I did, I registered the data frame into. One second, it's not working, but yeah, I registered that table or data frame into a temporary table called employee, and I just selected all the columns. This is how it works. We'll cover it in a lot of detail tomorrow. And tomorrow we will be covering a lot about Spark query optimizer and Catalyst optimizer, Tungsten engine, different kind of stuff. Okay, this is all for today, guys.